In this video, I'm going to go through a numeric example of calculating a determinant from a 3x3 matrix. I'm a little bit tired, so we're going to use a real matrix in this case. So when we're calculating our determinant, the method I want to use is that down diagonal minus the up diagonals, and I want to make sure that there's 6 terms and each one has 3 elements. So that first term is going to be -2 times 5 times 2. And I like writing it this way so I clearly see that there's 3 terms. Maybe I could do that in my head on a good day, but what if I drop a number? And now I need another down diagonal. I'm going to use the method of rewriting these first 2 columns so that I can clearly do those diagonals. The next one is 1 times -7 times 1. So this was my first term, my second term. My third one is 4 times 3 times 6. If you're most comfortable writing multiplication with the little x's, that's okay, unless you actually have x's as variables, in which case I wouldn't recommend it. So that's our third term. As you can see, I am going to run out of room, and that might happen on your paper, so feel free to just use multiple lines, leave space between things, be careful about assuming you can just do everything now in a small piece of paper. It's not going to always happen. So now, my remaining 3 terms are all going to be minus whatever. So my fourth term will be this diagonal, and so that's 1 times 5 times 4. Okay? And I am going to just kind of continue on to the next line in order to have enough space. So my fifth term, again minus, is going to be, and it helps if you write these diagonals, if you write your matrix elements spaced really well, 6 times -7 times -2. That's my fifth term. And then I have my sixth term, again minus because it's an up one, 2 times 3 times 1. Okay, so now I need to go through and actually do out the multiplication. I'll bring it together and see if I can add it up in my head. So that first term, 2 times 5 times 2, is 20, -20, and then -7, 4 times 3 times 6. Notice I can barely read my own handwriting, which is a bad sign. So that's 12 times 6, which is 72. I hope. And then -20. And now in this case, this is where you have to be careful. Okay, so 6 times 7 is 42, negative. So -42 times -2 would be +84 with another minus sign. Okay, and then 2 times 3 times 1. So notice that that was the 6th term, and it happens to be 6. Now, this is where it's tricky. Now I have to somehow either trust that my notes are right or see if I can do this in my head. This would be, let's start with 72, -20 is 52, -20 is 32, -7 is 25, -6 is 19, and then -84. So 19 minus 84 is the same thing as -84 minus 19. So this is -65. So the determinant of this matrix is -65. Again, might be something you need to calculate, but really this is just to practice this method. Eventually what we're going to be doing for finding eigenvalues and eigenvectors is actually having variables in here that we're subsequently solving for. So this is kind of the training wheels, because it is harder to find the determinant when you have a bunch of complex variables floating around that you're later solving for. So I hope that this has helped clarify it. Again, writing it out really explicitly like this just helps make sure that you haven't lost the minus sign or dropped a term anywhere.